Okay, welcome back everyone. In the last lecture we saw a type of diode circuit that we can use to process some analog signals. Basically we saw how to use a clipper circuit to clip certain portions of the signal that we are trying to process. Okay, we may choose to decide some part of the signal to pass and some part of the signal to not to pass to another circuit that we might be connecting to. In this lecture we will look at another type of circuit that is very useful in certain electronic signal and circuit applications. Okay, so consider this scenario that you are trying to amplify a circuit. Okay, you are trying to amplify circuit. Suppose it could be a speech signal. You are speaking into a microphone. A very realistic scenario is one that you see in programs like in concerts. Okay, a singer or an instrument is producing a very small sound. Okay, but the signal that everyone gets to hear from a loudspeaker is very well loud, right? So but the singer does not speak at such a loud voice. The voice or the speech signal generated by the microphone that the singer is singing into or the instrumentalist is playing into is amplified. Okay, so suppose I have a speech signal, a very simple speech signal, and it is usually a speech signal is very zigzaggy and all that, and we need to amplify this signal. Okay, we need an amplifier circuit, some sort of an amplifier circuit. Okay, we need to input this signal to an amplifier circuit and that will result in a larger signal. Usually you will see in the next parts of the course that amplifier circuits are made using transistors. Okay, now a very interesting caveat of using transistor circuits is that transistors cannot amplify negative signals. Okay, if your input signal has both positive parts of the signal and negative parts of the signal, and if you input that to an amplifier, what the amplifier does is that it amplifies the positive part of the signals, all right. Okay, it will amplify the positive part of the signal. Okay, but it will cut off all the negative part of the signal. Okay, no negative part of the signal will actually the amplifier will allow it to pass to the output. This is for speech processing applications. This is a very real problem. Okay, because the speech signal that you generated contained both positive parts and negative parts, right? It had both positive and negative parts. Both the positive and negative parts contain information about your speech. But if your circuit only amplifies the positive parts and cuts out the negative parts, then the output of your amplifier will be heavily distorted. Okay, this will be a very distorted signal, and well, we don't want distortions in our amplifiers. Okay, because then our music, the quality of our music will be severely degraded, and that won't be very pleasurable to hear. All right, so what is the workaround? How can we correct this behavior? Well, a simple way, since the amplifiers can amplify positive signals very well, right? It has no problem in amplifying positive signals. It cannot amplify negative signals. It actually cuts out negative parts of the signal. So a very easy workaround would be if I just shift this signal. Okay, shift my speech signal upwards. Okay, I shift my speech signal upwards like this. Oops, I shift my speech signal upwards. Okay, just you shift it horizontally. Okay, what I have done is I have just shifted this signal upwards so that all the negative parts are brought to the zero level. Okay, all negative parts are brought to the zero level. Okay, now the signal has no negative parts, so I can feed the signal directly to the amplifier. All right, I can feed the signal directly to the amplifier, and this amplifier can well amplify the signal well. Okay, it can amplify the signal very well. So The amplifier will output a signal like this. Alright, now I have to do another operation. What I have to do, that originally my signal had both positive and negative parts. To amplify, I shifted all the negative parts up to 0, then sent into the amplifier, then the signal from the amplifier came out. Now I have to shift it back. Okay, I first shifted it upwards. Alright, I shifted it upwards and then got this signal. Now I have to shift the output signal downwards, okay, to convert it to a signal that has both positive and negative parts. Alright, okay, so now my amplified signal has both positive parts and negative parts, and I won't have any distortion. So in many types of signal processing applications, we need to do these shiftings of the signal. Okay, we might need to shift the signal upwards or shift the signal downwards by a constant amount or something like that. Okay, so what type of circuits do we use to do this shifting? This is another application of diodes, that we can use diodes to perform these shifting operations, and the circuits that we use to do this are called clamper circuits. Okay, clamper.